Hello viewers, in today's lecture we are going to study how to find the integrating factor IF of differential equation of the form dy by dx plus py equal to q, and the other form of differential equation is dx over dy plus p1x equal to q1. So this is the first type and this is the second type, right? So a differential equation of the form dy over dx plus py equal to q, where p and q are functions of x only, is known as a first order linear differential equation, right? Similarly, the second type of first order linear differential equation is of the form dx over dy plus p1x equal to q1, and here p1 and q1 are functions of y only, right? Now in this lecture we are going to find how to evaluate the integrating factor of a first order linear differential equation which is of this form. So let us first take the first form, that is dy over dx plus py equal to q. Here the integrating factor is given by e, that is the exponential number e raised to integral of p, right, with respect to x. So this is the integrating factor of this type of linear differential equation, and the integrating factor of this type of linear differential equation is given by e raised to p1 dy, right? So here p1 is a function of y and here p is a function of x, right? So this is the formula for these two type of linear differential equation, and we can find the integrating factor. So let us take some examples. Now here we have this linear differential equation of first order, that is dy over dx minus y equal to cos x. Now what we will do, we will compare this equation with this equation. So we see that here the value of p is minus 1 and the value of q is cos x, right? So therefore the integrating factor of this type of linear differential equation is given by this formula, and this equation is of this type. Therefore the integrating factor is e raised to minus 1 dx, right? And we see that the integral of we have here integral of dx, so we have minus x. So this is the integrating factor of this linear differential equation. Now let us take this problem. Here we have the linear differential equation x dy over dx plus 2y equal to x square. So viewers, what we will do here, here we have to divide both sides by the coefficient of dy over dx in order to reduce this equation to this form. So dividing both sides by x, we have dy over dx plus 2 by x y, and here we have x, and here we have the condition x is not equal to 0. Now we see that this equation is of this form. So comparing this equation with this form, we have p is equal to 2 by x and q is equal to x, and the integrating factor is given by e raised to p dx, and p is 2 by x dx, and we have 2, taking 2 outside this integral, we have dx over x, and we have 2 times of log x, because the integral of 1 upon x is log x. This can further be written as log of x square, because taking this 2 to the power of x, we have e raised to log x square, and this is equal to x square. Why? Because here we have used the result e raised to log of f of x is equal to f of x, right? Now let us take this problem. Now here we have this differential equation, and if we compare this equation with this form, then we see that the value of p is cot x, right? And the value of q is 2x plus x square cot x. Now the integrating factor is given by e raised to p dx, so we have e raised to integral of p is cot x, and here we have dx, right? Now we know that the integral of cot x is log of sin x, and this e raised to log sin x can be written as sin x. So this is the integrating factor of this linear differential equation. Here again we have used the fact that e raised to log of f of x is equal to f of x. Now let us take this problem. Here we have this linear differential equation, and let us divide both sides of this equation by cos square x. So we get dy over dx plus y divided by cos square x, and here we have tan x divided by cos square x. Now this can be written as dy over dx plus sec square x y equal to tan x divided by cos square x. Now this equation is similar to this equation, so if we compare both these equations, we get p is equal to sec square x and q is equal to tan x divided by cos square x. Now the integrating factor of this linear differential equation is e raised to integral p dx, and the value of p is sec square x dx, right? Now the integral of sec square x is tan x, so this is the integrating factor of this linear differential equation. Now viewers, let us take this differential equation. Now here we have 1 plus x square dy over dx plus 2xy equal to 1 divided by 1 plus x square. Now if we divide both sides by 1 plus x square, we get dy over dx plus 2x divided by 1 plus x square times y is equal to 1 over 1 plus x square whole square. Now we see that this differential equation is similar to this one, right? So here we have this value is p, and the value of q is 1 over 1 plus x square whole square. This is a function of x, and q is also a function of x. So therefore the integrating factor is given by e raised to integral of p and dx, and here we substitute the value of p. We have 2x divided by 1 plus x square dx, and here we see that the derivative of 1 plus x square is 2x, so this is e raised to log of 1 plus x square, right? And this can be written as 1 plus x square. So this is the integrating factor of this differential equation. And here again we have used the fact that e raised to log of fx, e raised to log of this is fx, is equal to fx, right? And here we have used the formula that integral of f prime of x divided by f of x dx is equal to log of f of x, right? Now viewers, let us now study how to find the integrating factor of this type of linear differential equation, that is dx over dy plus p1x equal to q1, where p1 and q1 are the functions of y only, right? So here we will make use of this formula. So here I am taking the first problem of this type. So actually this equation is not exactly given in this form, so our first aim is to reduce this equation to this form, right? So what we will do, we will take this term to this side. So we have x plus 2y square dy, right? Now we can have dx over dy and x plus 2y square divided by y, and this can be written as x divided by y, separating the terms, and here we have 2y. Now if I take this term to this side, so we have dx over dy minus x over y is equal to 2y. Now viewers, see, this equation is now similar to this one. See, this is dx over dy, here we have dx over dy, then we have x, here we have x, and here we have q1. For q1 we have 2y. So if we compare both these equations, we get p1 is equal to minus 1 over y and q1 is equal to 2y. So the integrating factor is the e raised to p1, integral of p1 and dy, and for p1 we have minus 1 over y and here we have dy. So this is e raised to minus of log y, and see, this can be written as e raised to log y raised to minus 1, and this can be written as e raised to log 1 over y, right? And this is equal to 1 over y. So 1 over y is the integrating factor of this differential equation. And again we have used, here we have used the fact that e raised to log of f of y is equal to f of y. Now viewers, let us take this problem. Here we have 1 minus y square dx over dy plus yx equal to ay, and we have to find the integrating factor of this linear differential equation of this type, right? So what we will do, we will divide both sides by 1 minus y square, so we have dx over dy and plus y over 1 minus y square, this is x, and here we have ay divided by 1 minus y square. Now if we compare both these equations, we get p1 is equal to y divided by 1 minus y square, and q1 is ay divided by 1 minus y square. Now the integrating factor is given by e raised to integral of p1 with respect to y, and here we have e raised to p1. For p1 we can substitute y over 1 minus y square, y over 1 minus y square, and here we have dy, right? Now here what we can do, we will here we will take 1 by 2, or we can take minus 1 by 2, and in the numerator we can take minus 2, and here we have y, and divided by 1 minus y square, right? So multiplying the numerator and denominator by minus 2, we have this expression. Now see, the derivative of 1 minus y square is in the numerator, so this becomes minus half and log of 1 minus y square, right? Now this can be written as e raised to log 1 minus y square raised to minus 1 by 2. This can further be written as e raised to log 1 divided by 1 minus y square raised to 1 by 2, right? Now again, using the formula, e raised to log of f of y is equal to f of y, this expression becomes 1 over 1 minus y square raised to half, or this can be written as 1 divided by square root of 1 minus y square. So this is the integrating factor of this linear differential equation.